Good. So what are we covering tonight?
Right now, we're covering factoring quadratics by grouping.
Okay. Go ahead and give me the quadratic. We'll go through some of them.
Okay, so the first one is negative 7x squared minus 24x minus 9.
Now, when you say by grouping, that usually is applied to cubics, not quadratics.
Okay.
In other words, I don't need to use grouping to factor this.
Okay.
If I cannot factor it, then I can always use the quadratic formula, right?
Yeah.
Quadratic formula works 100% of the time with quadratics. Let's see if we can factor it without. If I'm going to try to factor this, in other words, if I want to spend a minute or two trying to factor it, it's worth it because it's easier than applying the quadratic formula. So if I'm going to try to factor this, what's my first step?
So first would be finding a common denominator.
No, it's really hard to factor when your coefficient is negative on the x squared term. So I'm taking out a minus 1. Leaving this. Now, this quadratic is much easier to factor than the original one. Maybe. We don't know yet. We haven't tried to factor it, but let's try to factor it. In other words, that minus 1 can just sit there, and that's fine. We don't need to do anything with it. Okay? So if I'm going to factor that remaining quadratic, work me through the steps. What's the first step?
So the first would be to find what adds to each 24 but multiplies.
Let's start with the very first step. The very first step is always splitting up the x squared term. In other words, understand that factoring is the reverse of foiling. You've been taught foiling?
Yeah.
Okay. So this term times this term is always going to equal to that term.
Okay.
That's the most important thing to consider. And therefore, your first step is to split up the 7x squared. Well, how can we split it up?
You could do 7 and 1.
Well, 7x and x. In other words, we have to make sure that those two things multiplied together give us that first term.
Okay.
Okay. Now figure out both signs. What do both signs have to be?
Positives.
Okay. And now what's the easiest way to factor 9?
3 and 3.
Let's just check and see if that works. Bingo. That works because we produce a middle term. It's always the middle term that is in doubt.
Okay.
Well, when I do the O and the I of FOIL, that's what produces the middle term. This gives me a middle term of 24x. That's the correct middle term. That means that's the correct factoring.
Okay, yeah.
Okay? So this was 2 steps. First of all, we had to get rid of the negative sign in front of the x squared. And if you ever have a negative sign in front of that x squared term, always factor out a minus 1.
Okay.
Because it's terrifically difficult to try to factor with a negative coefficient in the x squared. Mm-hmm. So automatically factor out a negative 1 if you see that.
Okay.
Okay, what else?
So next is negative 8x squared minus 15x plus 2.
Okay? Tell me what to do.
So first we're going to want to factor out a -1. So put down a -1, yeah.
What's that leave?
8x squared minus plus 15 minus 2.
Okay. Now all we have to do is factor that, which is not automatic, but it's certainly going to be easier than factoring it with a -8 in front of it. What's the first step?
So first is probably put in a 4x and a 2x.
That's what I would try. Could be 8x and 1x, incidentally. Doesn't have to be 4 and 2. But I always start with the two factors that are closest together.
Okay.
What's next? What's the next step in factoring?
Figure out what is
both signs are.
Yeah.
Always the next step, and it's always the step that my students want to skip.
Okay.
Don't skip it. That's perhaps the most important step. So what are both signs?
So the first side would be positive and the other side would be negative.
Well, not necessarily. Normally, plus minus is the same as minus plus, but not if you have two different coefficients in front of your x term. If you have two different coefficients, you have to allow for a plus minus or a minus plus.
Okay.
And this is the way I write it. Now, the rest of it's pretty easy because we only have two factors of 2. What are they?
They're 2 and 1.
I'm just going to randomly plug them in. Factoring is a trial and error process, especially with these kind of quadratics. Okay? In other words, I don't have any rhyme or reason why I put the 2 here and the 1 there. It's just there's only 4 possible combinations, right? It's either 2 and 1, 1 and 2, or 2 with the negative sign and 1, or 1 with the negative sign and 2. There are only 4 combinations. We are looking for the combination that produces 15x in the middle. Is this one going to do it?
I don't think so, no.
No, that's plus 4x. That's minus 4x. That gives you 0 in the middle.
Yeah.
Now that tells me a couple of things. First of all, tells me not only this is the wrong answer, but I'm not going to get anywhere if I move this 2 down to the negative sign. In other words, if I make this a 2 and this a 1, I'm going to get the same 0. Normally I would say I would get the same number, different sign, but 0 is 0. So in other words, 2 on the left is not going to work.
Okay.
Okay? So let's try 2 on the right. In other words, I'm going to start off with the 1 on the left. I'll start off there and go there. Does that produce 15?
No.
No, it doesn't. And by the same logic, if I move the 1 down to here and the 2 down to there, I'm producing the same number, different sign. I didn't produce 15 the first time. I'm not going to produce 15 the second time. So now what does that tell us? Now where are we at?
It means that the factors of 2 don't work.
Okay, so what does that tell us? Remember, there was another way to factor 8x squared.
Yeah. So it would be 1, 8, and 1.
So 8x times x is 8x squared. And now we can begin to see that we're going to get close to 15. If I put the 2 over there, Jesus, I already have 16x, right?
Yeah.
Well, if the 2 goes over there, the 1 has to go there. Now, if I check my middle term, I have minus x plus 16x. That's plus 15x. That's the right answer.
Okay.
However, just for illustration's sake, I'm going to put the 1 up here and the 2 there. In other words, I'm not going to use any logic whatsoever when I figure out how to start. I'm just going to use trial and error.
Okay.
Okay, so I try this, and what do I produce? I produce a plus 1x and a minus 16x, which is minus 15x. Well, that's the right number, but the wrong sign. When you get the right number, 15, but the wrong sign, negative instead of positive, then all you have to do is move those numbers down to the other sign. In other words, I'm going to move this 1 down to the negative sign. I'm going to move this 2 down to the positive sign, and that will give me a plus 15x. Always.
Okay.
And that's very useful to remember because it's a trial and error process. You may have 8 things to try, so it's good if you can eliminate 2 at a time. But in this case, we found our answer right there.
Okay. And then would the -1 go in like the outside of the final like 2?
Yes, the final answer is this. In other words, that if you leave the -1 off, you're not really factoring that expression.
Okay.
If you're solving an equation where that thing's equal to 0, then your -1 is kind of superfluous. You don't need it.
Okay.
Because the very next step, you're going to divide both sides by -1. Eliminating it. And then you just have 8x minus 1 times x plus 2.
Okay.
All right, what else you got? Done?
The next one is 12x squared plus 17x plus 6.
Okay. What's the first thing you want to do on problems like this?
Factor out the 12x squared.
Can't do that. In other words, in order to factor out something, you have to be able to divide every single term evenly by it.
Okay.
I can't even factor out a 6 because 17 is not divisible by 6. But
Okay.
the answer to my question was you look for greatest common factor.
Okay.
The last 2 problems you gave me, there was a greatest common factor, it was -1. This problem has no greatest common factor, okay? And it's going to be extra difficult because 12 has so many factors. And 6 has a lot of factors. So we are going to have lots of trial and error here. So where do we start? You've got to have a starting spot even if you're going to use trial and error.
Probably 4x and 3x.
That's where I always start, the 2 closest. May not be right. I wasn't right the last time, but it's the where you should start.
Okay.
Second step.
Probably 3 and 2.
Oh, both signs. Don't forget that second step. Why does everybody want to forget that second step? I don't get it. It's universal. 95% of my students consistently do not want to do that second step. I do not understand because it's pretty valuable. It's got to be plus plus.
Okay, yeah.
Okay. Now you're going to do factors of 6. Well, we've got 2 possibilities. Those 2 over there. And we got to get to 17.
Mm-hmm.
Well, if I try 3 there and 2 there, what's that get us to?
18. Or
Do
no?
the inside, do the outside.
Okay. So that would be 8 and 9, which would actually be 17, yeah.
That's the answer. First trial, we got the answer. Pretty unusual, but not that unusual. You'd be amazed at how often it only takes 1 or 2 trials to get the answer, especially if you consistently start with the 2 closest factors. In other words, we started with 4x and 3x, and we started with 3 and 2. Well, the answer could have been 12 and 1 and 6 and 1. You know, so we were very lucky. There were probably 8 possibilities there that we would have possibly had to try. And I don't know of a shorter way of doing it other than trial and error. Even the exotic methods they try to teach you, like the California method or the diamond method, stuff like that, they're still trial and error. There's nothing special about them. They don't have any magic way of doing these faster.
Okay.
I don't like the diamond method or the California method. I find it confusing. I find my students find it confusing. I don't even like to teach it. For one thing, my method isn't that hard. It makes more sense. Less confusing. What else we got?
So the next one is 2x squared. Oh, not 2x squared, 6x squared.
Okay.
Minus 13x plus 6.
Again, the more factors there are of that number and that number, the harder the problem is going to be.
Okay.
It just means there's lots of possible solutions. So, get me started.
So first, we're going to want to find the greatest common factor.
There is none.
Okay. The next, probably put in a 3x and a 2x.
Good starting spot.
And we're going to want to find the signs. So it would be probably just plus and minus for both sides.
Hold on. You do not get a plus from a plus and a minus. In other words, here's the thing that a lot of students don't get. Let me point it out. Whatever that number is, it produces that. Just like the first number is produced by this times that only, nothing else. So if I have a plus 6, then I can't have a plus and a minus. A plus and a minus would produce a negative number.
Okay.
So what must the signs be? They have to be the same.
So it probably, let's just do plus and plus. So
that does not produce this. In other words, you've got the first part right. They've got to be the same. To figure out whether they're plus plus or minus minus, look to the middle term. The middle term is negative, right?
Yeah.
That tells you they have to be minus minus.
Okay.
Okay. Now, the third step, factors of 6. Let's just go ahead and try 3 and 2 and see what happens. What does that give us?
That gives us negative 6.
Negative 6x.
And negative 6x.
Which is minus 12x.
Yeah.
That isn't right then. So what's the next step?
Probably flip-flop them. So
yeah, try the 2 on the left and the 3 on the right. And it could matter because remember, this is 3x and this is 2x. So it is going to produce a different number.
Yeah.
Bingo. We got our 13x. The key to factoring is to realize that this term is the result of 2 different terms. This term is the result of only one term. This term is the result of only the two outside numbers being multiplied together.
Okay.
You'll notice here, let me just emphasize this. If I multiply those two together, I get x squared minus 5x plus 3x minus 15. Okay? Notice that the minus 15 came only from that times that. And the x squared came only from that times that. The middle term, which is going to be minus 2x, is a combination of the O and the I in FOIL. In other words, the middle term comes from that times that plus that times that.
Yeah.
So it's that middle term that's the tough one to get. First term is always only one term only, and the last term is one term only. It's the middle term that's based on two different multiplications. Once you get that, factoring becomes a lot more clear in your head.
Okay.
Once you understand that principle.
So the next one is 8x squared plus 112x plus 392.
First step.
So first, you actually have a 329.
Oops. Yeah, well, I knew that was wrong because I knew it was an even number. What was it, 392?
Yeah.
If all numbers are even number, you can at least take a 2 out.
Yes. So that would be 2 would be the greatest common factor?
Actually not. Here's another little rule that's worth knowing. A number is divisible by 4 if its last two digits are divisible by 4. Well, I know 8 is divisible by 4. I know 12 is divisible by 4. And I know 92 is divisible by 4. So I'm going to take 4 out because I know all three of these numbers are divisible by 4. That might not be the greatest common factor, but I'll find out quick enough.
Yeah.
Whoops. 28x. Let's see, if I divide 4 into that, I get 98. Now I can see I still have all even numbers. Which means I can definitely take another 2 out.
Okay.
So that makes that 8 instead of 4. And leaves me with a simple quadratic. I don't mean simple in that it's easy necessarily. What I call simple means it has a coefficient of 1 in front of the x squared term. Those are always easier, right?
Yeah.
Okay. Factor that. Step by step.
So first, we're going to want to put x's in.
Second?
Probably put 7 and 7.
Nope.
Oh, yeah, 7.
Second step is to figure out the signs. Both signs. Not one. Both signs.
So both would be pluses.
Right. In other words, you cannot produce a plus 49 unless both signs are the same. So it's either plus plus or minus minus. And then you just look to the middle term to see which it is. And it's plus plus. Now, what factors of 49 are there?
7 and 7.
And we can see immediately that's going to produce 14. In other words, if I do my inside, that's 7x. I do my outside, that's 7x. That's 14x. So that's the final answer. And one thing to learn from this is you don't have to figure out that every number is divisible by 8. It happens to be And that's one way you could do it. In other words, you could look at your starting problem and see if you could divide 112 by 8 and see if you can divide 392 by 8. And if you can, then factor out an 8 as the first step.
Yeah.
But dividing by 8 in your head is a lot harder than dividing by 4, mainly because of that rule of 4. In other words, all I need to see is the last two digits. If I give you this number right here, that is divisible by 4 because 16 is divisible by 4. All I need. Okay. Last two digits only.
Okay.
All right.
So the next one is 64x squared minus 144x plus 81.
Well, 81 is divisible by 9 and also 3. But none of the other numbers are divisible by 9 or 3. No, this one's divisible by 9. You know how you can tell if a number is divisible by 9?
No.
Its digits add up to 9.
Oh.
144, 1 plus 4 plus 4 adds to 9. That makes it divisible by 9 no matter how big the number is.
Okay.
If I gave you a number like this, 1, 0, 0, 0, 0, 8, 0, that's divisible by 9 because the digits add up to 9.
Okay.
And those kind of rules really come in handy when you're trying to find greatest common factor.
Mm-hmm.
Well, 64 is only divisible by 8s and 4s and 16s and numbers like that. So I can't find a single number that divides evenly into all three of these numbers. So I'm going to have to work with this quadratic. Now, usually when they give you big numbers like this, even though the number 64 has about 12 different factors, they're not going to give you the one that requires you to be 64 and 1. They're just not going to do it. What are the two closest factors of 64?
8 and 8.
Let's start there. Might not be right. That's a great starting spot. Second step.
We're going to want to find the signs. So
Are they?
Negative and negative.
And what are the two closest factors of 81?
9 and 9.
Worth giving it a shot. Bingo, it works. That's 72. That's 72. Actually, that's minus 72x, and that's minus 72x, but it does indeed give us our middle term. That's always what you're looking to produce, is that middle term. In other words, the moment I split it up into 8x and 8x, well, I know this term is right. And the moment I split it up into minus 9 times minus 9, I know that term is right. So there really is only one term you have to check, and that's that middle term, the hardest term to get right, because it's the result of two different terms added together.
Okay.
Okay? But when you see big numbers like this, you're going to get answers where it's the two closest factors almost every time.
Okay.
Mainly because if this was the correct answer, let me just... It would take you forever to find it.
Yeah.
Could have split the 64 up into 32 times 2. I could have split the 81 up into 81 times 1.
Okay.
Now, that does not give us 144, but I'm just illustrating how difficult this problem could be if they wanted to make it they could make it so that this was the answer. It would just take you 20 minutes to find it. Well, they're not going to give you a lot of 20-minute problems. So when you see this problem on a test, know that almost certainly it's going to be the closest two factors in both cases, with the x squared and with the 81. Otherwise, it would be too hard of a problem.
Yeah. So the next one is 49x squared plus 70x plus 25.
Is there a greatest common factor?
I don't think so, no.
What's the most obvious solution that satisfies that number and that number? We're not going to worry about the middle number yet. But
So
what would be 7x times 7x, right?
Yeah.
What are both signs?
Plus.
What's the best way to factor 25?
5.
5 and 5. And sure enough, that gives you that as the middle term. See why?
Yeah. Oh, yeah.
So, again, we got a quadratic with big numbers. You can almost bet money that it's going to be 7x plus 5 times 7x plus 5 right off the get-go.
Yeah.
Wouldn't have to be. I mean, they could make this number, 220 here, and then I'm going to have to use maybe 25 and 1 as factors of 25. But like I said, they're going to, when they give you big numbers, just assume that it factors nicely. And it almost always does on the first attempt.
Okay. So the next one is k to the 6th minus 9k cubed plus 14.
All right. This is a bit of a sticky wicket. Trying to figure out how to explain this to you. First of all, quadratics do not have to be the way, this is what I call a quadratic in disguise. You know why? Because this number is twice that number.
Yeah.
That's what quadratics are. Normally you have a quadratic, this number is twice that number, right?
Mm-hmm.
Okay, so there's a couple of ways we can deal with this. The most straightforward way, split the k's up.
Okay.
Split the k to the 6th up. That's what I should have said.
So that would be k cubed.
That's one possibility. It could also be k to the 4th times k squared. But, again, going on the premise that we're going to use the two closest factors, 3 and 3, are closer than 4 and 2.
Yeah.
What are both signs?
Both sides are negative.
Yeah, you see why that makes the problem so much easier once you get both signs?
Yeah.
Then you just have to figure out factors of 14. There's not that many. There's 14 and 1, and there's 7 and 2. It's going to be one of those two.
Mm-hmm.
What are we going to start with?
Let's do 7 and 2.
Always the two closest.
Yeah.
This is an integral part of the solution, incidentally. This, what I call my double smiley faces, is not just to check your answer. when you're doing some of these harder ones, it's part of the process of solving it. Bingo.
Okay.
We got our middle term. That's the only term we have to check. We know the first term's right. We know the last term's right.
Okay.
Now, I don't know if it's worth, it probably is worth telling you the following. That was the most straightforward way to do it. Sometimes you're going to get problems that are a little more complicated than this. It's not going to be that easy to do it straightforward. So I'm going to teach you a method called substitution.
Okay.
I'm going to let x equal whatever this term is right there. Now this quadratic becomes x squared minus 9x plus 14. You can easily factor that. X minus 7, 2. Well, x was actually k cubed, so it's k cubed minus 7 times k cubed minus 2. That's a slightly different way to do it, but it's going to be powerful when you come across, that's not really quadratic. This is a 6th degree polynomial, so I can't really call it a quadratic, but it's a quadratic in disguise.
Mm-hmm.
Similar to something like this. You're familiar with the e function?
Yeah.
Okay. This is a quadratic in disguise because this term is twice that term. So if I want to factor this, I'm going to split up the e to the 2x, and it splits up like this. When I multiply e to the x times e to the x, I get e to the x plus x, which is e to the 2x.
Okay.
Now, I know the signs have to be opposite, because that's the only way I could produce a negative sign. Don't have much choices on the 2. I can factor it this way, which gives us a plus e to the x as the middle term. Well, that's not right. So let's factor it the other way. Let's swap them. Put the 1 on the left, the 2 on the right. Now you'll notice that gives me a plus e to the x. This gives me a minus 2 e to the x. Add those two together, you get minus e to the x. So
Okay.
that's the middle term. So this is another type of quadratic in disguise.
Okay.
And it's not just these functions that it works with. What if I had sine squared of x minus sine of x minus 2? Well, that is a quadratic in disguise in trig functions. So sine x, opposite signs. 2 goes there, 1 goes there.
Okay.
Okay? All right, what other? I don't know if you're going to get problems like that, but I thought I might as well cover it. If they gave you a k to the 6th, they're certainly capable of giving you an e to the 2x.
Yeah. So the next one is n squared plus 14nm plus 33m squared.
Okay. This is a little different. How are we going to break up the n's?
So find a...
No, just break that up.
Okay.
There is no common factor. There's no greatest common factor. There's no number that divides into 1, 14, and 33. And there's no variable that divides evenly into n squared, nm, and m squared.
Yeah.
So it's a normal quadratic. Split up that first term.
So it would just be n and n.
What are both signs?
Positive.
Now we got to split that up. There's only one. There's a couple ways to split that up. What's the most likely way?
Probably 3 and 11.
Yeah, but it's not 3. It's 3m and 11m. Remember that this times this has to equal that.
Yeah.
Always. Now, let's see if that gives us the right middle term. Does it?
I think so.
Yeah.
Yeah.
In other words, this term is 3mn. This term is 11mn. Add them together, you got 14mn.
Okay.
It doesn't matter if it's nm or mn. The associative property holds.
Okay.
Okay? So when they add this second variable, don't let it get you. Just means that there's going to be a variable in the second part of that.
Okay. So the next one is negative 5p cubed minus 5p squared plus 60p.
First step.
Factor out the negative 1.
You can factor out more than that. Don't overlook greatest common factor. It's frequently the only way you're going to solve it is if you take the full greatest common factor means exactly what it says. The greatest common factor, not a factor. You can definitely factor out a negative 1, but you can also factor out a negative 5, and you can also factor out a negative 5p.
Yeah.
Now, let's just talk about that for a second. Greatest common factor means that if I divide every term by my greatest common factor, they all divide evenly. Is that true?
Yeah.
In other words, yeah, this one comes out to be p squared, this one comes out to be p, and this one comes out to be 12. So they definitely, that's the way you check and see if something is a greatest common factor, is it has to divide into every term. Every one of them, not just two of them, every one of them.
Okay.
Now, what's left over after you divide every term by negative 5p?
P cubed plus p squared.
Hold on. Remember, we're factoring out a minus 5p. So the first thing you do, once you write that first term, do stop and check to make sure it's right. Don't wait until you factored the whole thing and you finish the problem to check your work. The best way to check your work on math is immediately. In other words, is this times that equal to minus 5p cubed?
Okay.
Is it?
Yes.
Okay, that's correct then. Let's go to the second term.
So the next term would be plus p.
Now, multiply that times that. Make sure you get that middle term.
Okay. Yeah, I get that.
Okay. And now finally, the last term is what?
Plus.
It's actually not plus. I tricked you accidentally. I made a mistake. Remember, we're dividing that by minus 5p. What do you get?
Negative 12.
Okay. Now, look what we got. We got us a nice, easy quadratic.
Okay.
So, factor that. It's easy except for one aspect of it, which does tend to trip up students every now and then.
So first it would be P and P. And then plus 6 minus 2.
Just do the signs.
Oh, okay.
Trust me, it's the best way to do it. Just do the signs.
Okay, so plus and minus.
In other words, separate this process into 3 distinct steps.
Mm-hmm.
Don't do it in 2 steps. Don't do it in 1 step for sure. And I'm telling that to anybody. I'm telling that to Albert Einstein.
Mm-hmm.
Do this thing step by step. Okay? Now, what's the 3rd step? Can you verbalize the 3rd step for me? Factors of 12 that do what?
That are closest together.
No, that's what we're going to try, because there are multiple factors of 12. But it's factors of 12 that subtract, because of that, to what?
To P.
Not to P, the coefficient of P. 1.
1. Okay.
It trips people up here. Is because the 1 is not written, they don't see it.
Yeah.
But it's still there. So I'm definitely looking for factors of 12 that subtract to the number 1. What would be those factors?
4 and negative 3.
Well, just 4 and 3.
Okay.
I'll explain that in a moment. In other words, don't consider these signs. Not yet. Not when doing this step.
Okay.
I have found 2 factors of 12 that subtract to the number 1. That's all I'm looking for. Now, there is a 4th step to solve this problem. I have to put the larger of the 2 factors with the sign of the middle term. So that tells me to put the 4 with the plus and the 3 with the minus. That's the last step.
Okay.
And that 4th step, you're always going to have that as long as you're dealing with a negative sign right there. Because you're always going to have plus minus, and then you always have to put one of the factors with the plus sign and one of the factors with the minus sign, and you got to get it right. And the way you do that is to look at the sign of the middle term, put the larger factor with that sign.
Okay.
What else, John?
1 second. I just gotta get it to load in. So next is x to the 8th minus 8x to the 4th.
4th, yep. I knew that was going to be 4th because that's the only thing it could be. If it was anything other than x to the 4th, you don't have the knowledge yet to do this. Mm-hmm. So the only way it could possibly work is if that was half of 8. Okay, keep going.
Plus 12.
So, this is another one of those quadratics in disguise. Now, you can use the substitution method if it makes it look easier to you, but you don't have to. The substitution method would be what? I'm going to let u equal what?
So, u would equal, u would equal,
this one right here.
Okay, yeah.
Middle one. So that would be x to the 4th, which makes u squared equal to x to the 8th.
Okay.
So now this whole quadratic becomes u squared minus 8u plus 12. Well, that's a standard quadratic that you can factor easily.
Okay.
Okay? So, using substitution works fine. Always. As long as you know, just substitute that middle term for whatever letter you're using. But we don't have to use it. This is actually easy enough that we can probably do it without using u substitution or any kind of substitution. How are you going to split up the 8, x to the 8th?
X to the 4th and x to the 4th.
Again, it doesn't have to be like that, but it's probably like that.
Mm-hmm.
What are both signs?
Plus and minus.
You don't get a plus if they're plus and minus.
Oh, so minus and minus, yeah.
And what are the best factors for 12?
4 and 3.
Does that produce 8 in the middle?
No.
Okay, then it's not 4 and 3.
Oh, 6 and 2.
Yeah. In other words, if it's not the two closest ones, try the next two closest ones. And that does produce minus 8x, so the fourth in the middle.
Okay.
So these kind of problems that are kind of quadratics in disguise, these are almost simpler to do this way, the way we just did it. No U substitution. Have they taught you that substitution method?
I don't think so, no.
Yeah, they probably just expected you to do it this way. The problem is this could actually, there's a lot of ways to split up x to the 8th, right? I mean, I could have split it up like this.
Yeah.
So U substitution avoids making that error. Because when you use U substitution, you end up with a true quadratic, not a quadratic in disguise.
Okay. And so the next question is, let's load up for a sec.
Have you had trig yet, Jonathan?
I did it in geometry, yeah.
Okay,
But
you've had a little bit of trig.
yeah, a little bit.
Not enough that they're going to give you trig questions or trig equations.
I don't think so.
No, they won't. When you take a full trig course next year or whenever, then you'll get trig equations that are quadratics and have to be solved as quadratics.
Yeah.
In other words, something like this: sine x minus 1 times sine x plus 2. That after we factor it, we get it. Now when you solve for it, you know that sine x has to be equal to 1. Mm-hmm. This is impossible because sine x can never be equal to minus 2. So the only solution to that is 90 degrees. When x angle is 90 degrees. And in other words, what I'm saying is that quadratics can come into play with trig functions or exponential functions or a lot of things other than just polynomials.
Okay.
And they're necessary. You've got to be able to factor that. In other words, this started out as sine squared x plus sine x minus 2 equals 0. In other words, that's the equation that I had to solve, and you solve it by factoring, and then you know that after you factored it, one of them has to be 0. And it's this one right there. It has to be 0.
Okay.
All right, what else?
Next one is x squared minus 11xy plus 28y squared.
These look harder because they got two variables, but they're not really harder. Just do exactly the same process you would do any quadratic. First
up, so x and x.
Second step.
I'll find the sign, so it'd be negative, negative.
Third step, you need factors of that.
Mm-hmm.
Well, what are the two best factors to start with?
7 and 4.
7y times 4y. You can't forget the y. Okay? Because it plays into this middle term. That middle term is 11xy. Does this solution work?
Yes.
Yeah, it does. And that's another thing. When they give you more advanced quadratics, like two variable quadratics like this, you can be pretty certain that the most straightforward solution is going to be a solution. These actually become easier problems than the other ones. Because there's not, I know it's going to be 7 and 4. It's not going to be 14 and 2. They don't give you 14 and 2 answers when they give you 2 variables. They just don't.
Okay.
So these problems are going to be easy.
Okay. So the next is negative 5h to the fourth minus 15h cubed minus 10h squared.
Have they taught you how to do cubics?
I don't think so, no.
Okay. So when they give you a quartic like this, you know there has to be something unusual about it, right? Otherwise you don't know how to do it. They haven't taught you how to do it.
Yeah.
So let's start with greatest common factor. Always.
So the greatest common factor would be negative 5h squared.
Perfect.
Yeah.
And what that's going to leave behind is a normal quadratic. What is it?
H squared plus 3h plus 2.
Hold on. Check as you go.
Okay.
If I do plus 3h, does that produce minus 15h cubed?
Yes.
Yeah, it does. Sorry, I made a mistake mentally thinking about it. But it's a good point is check as you go, not after you're done. Because if you make a mistake on that sign, let's say you put a minus sign there, and you wait until you finish the problem, you're going to have no idea where you made your mistake.
Okay.
That's the advantage of check as you go.
Mm-hmm.
What's the last term?
The last term is plus 2.
Yeah, now that's a real easy quadratic to factor.
Mm-hmm.
What is it?
So
It's really only one choice, isn't there? There are no choices on this. This is almost one you can do in one step. It's got to be h plus 2 times h plus 1.
Yeah.
That's the only possibilities. In other words, I can put the 1 on the left and the 2 on the right, but that's the same answer.
Mm-hmm.
And that works. Now, I can't leave that off. If you leave that off, you will get deducted. In other words, if you were to give just that as your answer, you're taking points off.
Okay.
You've got to remember that greatest common factor that you took out follows all the way down, especially when you're factoring an expression. If you're factoring an equation, like if I turn that into equation, well, it's still important. Because that means one of the solutions is h equals 0.
Okay.
It's not just h equal, in other words, h equals minus 2 and h equals minus 1. Those are two solutions. But you also have, that can be 0. So you can have h equals 0.
Yeah.
And if you don't carry that down, you won't pick up that solution and you will lose points for sure. So whether you're solving an equation or just factoring an expression, don't forget that greatest common factor that you took out.
Yeah.
All right. John, you got any final questions for tonight?
I don't think so, no.
Well, I think that should help you a lot.
Okay.
What we covered tonight.
Yeah.
You got a test coming up or something. That should be good practice for it.
Yep.
All right, John, I will talk to you next time.
I'll talk to you next time, too. Have a good night.
You too.